So to derive the formulas for mean and standard deviation of a binomial random variable, let's start with one trial. So in other words, we're looking at B1P, where P is the probability of success. So if we look at the probability distribution, we could have 0 successes or 1 success. The probability of a success is P. The probability that we don't get a success is 1 minus P. And we know that the mean of a discrete random variable is found by taking the value times its probability and adding them all up. Well, 0 times 1 minus P is 0, and 1 times P is P, so that mean is P. And for standard deviation, we took the square root of each value minus the mean squared times its probability and added up those values. So let's simplify this. 0 minus P is negative P squared is P squared. So we have P squared times 1 minus P. 1 minus P squared is 1 minus 2P plus P squared. We're going to multiply that by P. Distributing everything in, we have P squared minus P cubed plus P minus 2P squared plus P cubed. Now at this point, we can simplify more because P cubed and negative P cubed cancel. And then we have some like terms. And so this becomes the square root of P minus P squared. And if we factor out a P from that, we get the square root of P times 1 minus P. So again, these are the mean and standard deviation for a binomial variable with one trial. But now we know we have n trials. And we know that those n trials are independent. So we're adding x, or really n different x's. And we said if we're going to do the mean of x1 plus x2 plus etc. up to xn, we're going to take each of those individual means and add those up. Well, each of those means is P, and there's n of them. So the mean of these n x's is n times P. Now for standard deviation, we have to use our Pythagorean theorem of statistics because standard deviations don't add, but variances do. So we can take the variance of x1, add it to the variance of x2, add all those up to the variance of x sub n. And so if we go back to our sigma, our standard deviation, which was the square root of P times 1 minus P, and we square it to get the variance, we're going to get P times 1 minus P over and over n times. And so that standard deviation becomes the square root of n P times 1 minus P's. And that is where the formulas that we saw on the formula sheet for the mean and standard deviation of a binomial random variable x came from. Mean is going to be n times P, which is logical, and then the standard deviation is going to be the square root of n times P times 1 minus P. And that is where those formulas came from.